Hello students, so in this lecture we will discuss about crystal growth in semiconductors. Now, an important difference between the growth of elemental and compound semiconductors is the difficulty in maintaining the stoichiometry. As you know that take element silicon and germanium, these are the elemental semiconductors, and say gallium arsenide, indium phosphide, these are binary compound semiconductors, and indium, say you can have also compound consisting of indium, gallium arsenide with different mole fractions based upon X and Y. So these are quaternary, these are ternary, these are binary, these are elemental, and you can also have indium, gallium arsenide and phosphorus based upon the mole ratios X and Y. So that becomes the quaternary. Now, stoichiometry comes into the picture when you are not only for this ternary and quaternary compounds. Stoichiometry means these X and Y values. So it is very difficult in the case of compounds and semiconductors, especially in case of ternary and quaternary semiconductors, to crystal growth. Now, if you look into this word stoichiometry, it actually is the correct chemical ratio of the compounds constituent elements. The chemical ratio of the compounds of the constituent elements in the compound. That's what stoichiometry means. So this has to be maintained. That means this X and Y values. At the same time, so one of the points, at the same time, controlling the thermal parameters determining the crystal perfection is also required. So as you know, temperature plays a very important role in crystal growth. So thermal parameters or control is also required in crystal growth. Now, why is it so? Because these materials usually have a volatile component at high temperature, so that has to be taken care of. So volatility is a factor. Like for example, if we take gallium arsenide and indium phosphide, yeah, these are the group 3 and these are the group 5 elements. So the group 5 elements, that means the arsenic and the phosphorus, they are more volatile compared to the group 3 elements. That means they evaporate readily, leaving behind the group 3 elements. Now, this property of evaporating one of the components and leaving behind the rich other component, this is called a name. This is called incongruent evaporation. Incongruent evaporation and is detrimental, is not welcome in case of a crystal growth. Now, the semi-crystal materials that are usually well known, as in the case of silicon and germanium, they are usually divided into two groups, two categories: substrate or bulk crystals. So, take single crystals, two categories: substrate crystal or bulk crystal. Now, from the name, we can see that the substrate crystal is formed when the epitaxial layer is grown on a substrate. That means you need to have a substrate for it, and there will be an epitaxial growth on it. This is a substrate crystal. So the substrate is acting as a seed for the it actually constitutes the seed. It also plays a role in the fabrication of devices, and in case of device fabrication, it also is important because it provides something called contact region. It also provides the substrate and device isolation. That means the components can be isolated. There won't be any mix-up. Whereas a bulk crystal it doesn't require any substrate. It grows. Suppose you are putting a thin glass slide into where the liquid form of the crystal is there. If you put it and it automatically grows. So this is you don't require any formation of a substrate on a basis. So let's take into a detailed aspect of the bulk crystal growth. Now, bulk crystals of compound semiconductors are produced by two common techniques. Both are also known as melt growth techniques. So you need to have a melt. In the first, the starting material and the seed crystal are placed in a quartz tube. So there is a starting material. And there's a seed material. They are both put inside a quartz tube, and which is again placed in a furnace. So that is why the name of this technique is called furnace growth. In the second technique of bulk crystal formation, as I've showed you in my previous slide, this technique, here what happens is the seed crystal is dipped in a melt containing a pressurized vessel. So seed is then dipped melt which is pressurized under pressure. And gradually pulled out. And it is pulled while being rotated at the same time. So this is a melt. You put the seed inside and you pull it with amount of rotation. This results in single crystal growth of the substrate ingot. So these are the two techniques in bulk crystal formation. Now, the furnace techniques has also got two different ways. One of the ways is called horizontal enrichment technique. And the second one is called Stoichiometry technique. Spelling is a little complicated. Stoichiometry. So what I will do, I will give an assignment to write about these two techniques. Take it as an assignment and try to submit it on Friday. Not on Friday, today is 24th, so try to submit it within 3 days, so 27th of June. This is you find out what these two techniques are about: horizontal enrichment and Stoichiometry technique.